4.5 Sources and uses of alkanes. The major source of alkanes is petroleum, that is crude oil. It can be separated into kerosene, gasoline, and many other products. So most of the untreated petroleum is not good for gasoline, and so they frack it, they crack it and break it into smaller alkanes that are suitable for gasoline. This tends to make straight change, which causes knocking. And so the compounds are then reformed into branched hydrocarbons and aromatics. So these are the different compounds and the number of carbons. And you can see all the different natural products that can be made from the petroleum fractions. When you go by a refinery and they have those tall towers, what they're doing is they're refining the oil, and they are separating it into these groups, and then the larger ones get cracked to make more of the gasoline, which is the more useful one. Okay, so let's then go on to drawing Newman projections. This is a special way to draw molecules so that we can see which groups are interfering with other groups. It gives us a more 3D feel for what's actually happening. Molecules can rotate around carbon-carbon single bonds, and they form different three-dimensional shapes or conformations. These are not constitutional isomers. They're just the way the molecule can flop around in 3 dimensions without changing any of its bonds. So below we have 3 different ways to draw ethane. We can do the wedge and dash. Remember, the wedges are the atoms that are coming out toward us. So this is coming toward us. This one that's on a dash is going away from us. And this one that's on a line is sitting on the paper. That bond is on the paper. You can do a sawhorse, which you can kind of see how they are in 3-dimensional space, and we can do a Newman projection. So let me get out my models. Go. Here is my ethane. And the way the Newman projection is drawn is it's drawn so that the carbons that you're looking at, the 2 carbons, this one and this one, are behind each other. So it's drawn like this. So we draw a dot for the carbon that's in front, and this hydrogen here is going straight up. So I'm going to pick a hydrogen going straight up. These 2 are making kind of a Y form. So we'll make a Y form. The back carbon is denoted by a larger circle. And you see here, this one is coming straight toward me, so I'm going to draw a hydrogen coming this way, and then the 2 hydrogens going up are kind of going in a Y, so we get this and that. So that's what you're drawing when you're drawing a Newman projection. The 2 carbons are right behind each other. They are right here and right here, and then you draw the groups out from around that. Now, when you're identifying your 3 groups, you want to make sure you realize whether the front carbon is up or down. If it's up, place it up. If it's down, place it down. If it's on a wedge, put it to the right. And if it's on a dash, put it to the left. And that's what they've done here. So the wedges are on this side, and the dashes are this way. So if you're looking at the molecule from this angle, you would see, if this is your eye, it's a really bad eye. These are the wedges, and those are the dashes. So we'll do some examples, see how that works. I'm going to move the camera back down so we can see. So we just see the paper. There we go. So this is our first molecule. We're wanting to draw the Newman projection as shown. So first we want to ID the two carbons that we're looking at. This is one of the carbons, and this is the second carbon. So the first carbon has 3 methyl groups on it. This one is going down, and these two are going up in a Y. So we've got this, and we'll put methyl. Just put M for methyl. The carbon that's behind, I'm going to do it in blue. We'll do this one. It only has 1 methyl group on it, and it's going up. So it will go like that, methyl. And then there are 2 hydrogens here. They aren't in my picture, but we know that every carbon needs to have 4 bonds. Okay, so now let's look at one that has wedges. This is our first carbon. Okay, so we've got 3 groups on this. We've got a chlorine, and methyl, and a hydrogen that's not shown. The chlorine is on a wedge. That means it's going to go here. The hydrogen that's not shown is on a dash. And then there's a methyl group down here. I never leave myself enough room. There's a methyl group down here. Now let's do the carbon that's behind. So again, if we have chlorine on the dash and we've got a methyl group on the line, there must be a wedge that has a hydrogen, because you always have 2 lines, a dash, and a wedge. All right, so here we go. The wedge is down, and it's coming, and it's a wedge, so it's going to be here. The dash is also down, but it's a dash, so it's going to be on the other side. Remember, this is the wedge side, and this is the dash side. And then we also have a methyl group, and the methyl group is headed up. So let's look at this guy. We want to ID the 2 carbons that we're looking at. We'll make the first one red. It's got an ethyl group attached to it. This is the other carbon that's attached, so we don't want to count it yet. It's the one that'll be behind. It's got a methyl on a dash, so there must be a wedge that's just not shown, has the hydrogen. So we do our All right, so we're going wedge, that's this way, dash, the methyl group, and down is going to be this ethyl. See, that ethyl goes down, so. And then we'll do this one. This one has got an ethyl group attached to it. These two carbons will be an ethyl. And it looks to me like they're going up. And it'll have two hydrogens attached. And they're the same. It doesn't matter. All right, so then let's look at the last example. We've got this carbon that we're interested in and this carbon that we're interested in. So first the red one. It's got, the red one has a methyl group going up. It has two hydrogens on it as well that just aren't shown. The blue has chlorine, and there's a methyl group here. Okay. And these are not wedged or dashed because there's no, it doesn't matter which side they're on because there are two of them the same. It's not a one that matters. Okay, so let's look at the conformation of ethane and propane next time.